scientific right way to compare two competing hypotheses. You should use the base factor, and those ratios are basically the same thing. And the other thing is, we are probably going to need very sophisticated solutions to make induction approximations work in the real world for incremental learning. Without incremental, it just won't work at all.
Okay, it's time for coffee break, but probably we can have one more very short question, if it is very short.
I don't know if mine's short. Could somebody give an intuitive explanation of what Levin search is?
Well, you represent programs as binary strings that are executed by a universal Turing machine. And you can order those binary strings by length lexicographically. So then you start executing them one by one. And you attribute the time of execution. It depends on the length of the program. So you execute a shorter program for a longer time and a longer program for a shorter time. And
the important thing is that the whole running time is allocated in proportion to the a priori probability of a candidate program. So that's Levin search. And it is necessarily so. And since there's a halting problem, you can't just allocate this, but you have to start with a small time limit, and then you double this time limit in each iteration, and so that you this watchdog policy overcomes the halting problem in this case.
Essentially, you're setting a time limit, and you or do your trial programs in order of the increasing, as you guys is saying.
In proportion to
but
a
it's
further
not,
probability.
But it's not necessarily just the length of the program, because that's just with binary strings, and it's the computational cost. So that sometimes you might, instead of having just a short program, maybe a longer one is actually faster than a short one, so that it's allowed to have more time too, because it was faster. So it's a way of ranking programs, and I think they just use the length and the computational cost. But you could have other measures of how fast your program could do different aspects of your program that could keep it within this time bound. But if you search and all the programs don't find anything, then you can raise the time and you start your search over. But you have to be careful when you start the search over, because you don't want to do the same thing that you did last time. So you need to, if you're going through the programs, you need to change things a little bit. And I'm not sure how Ray was able to do that, but it is important, because you don't want to learn the same things over again. You want to have some way of knowing what you did, because it's very important with learning to remember things. And a lot of these searches, they start and they find the thing, and then they go back and they forgot the whole thing. So part of Ray's work with Levin search is how to change things or save things in order for the future search. It's all part of trying to make it more and more practical, which it still isn't.
That's called adaptive Levin search. So if you find out the ordered optimal problem solver, that's something very simple you can just understand.
Okay, let's thank again.